Welcome back, guys. Again, we start again a new lesson 4, absolute value functions. The same chapter 16, and now we start with how to know the absolute value. How do you graph the absolute value? How to graph and analyze absolute value functions? Absolute value defined as distance of number from zero on a number line. This the old thing. You remember this symbol. But if we're dealing with absolute value for function, we will graph it. And we can consider this one a special case of piecewise function. So we have absolute value, the old thing, from 0 to your number. This gives you the absolute value, the distance between this two numbers, 0 and your number, positive or negative, whatever. And now we graph today with the same thing with this function. Now we have example like this. If I give you example 1, graph of f of x, absolute value of x, then analyze the graph. So we have to, how to make your graph. So if you have equation or absolute value like this for this function, you have to know you're dealing with two things, positive or negative. But I have to start with this one. My equation without this absolute, if I take it and put it equal 0, this is my equation. So if x equals 0, my y also will be 0. So the starting will be with 0. This is my starting. So my x. If I substitute it here, my y will be 0 also. So I have to take something after and something before. So after 0, 1, 2, 3, and negative 1, negative 2, negative 3, like this. Okay? Now we have to substitute all of these values here in your function. So this is clear to dealing with this one. So negative 3, if I put it here, will be 3 and so on. So we start with now 0 will be 0. Now 1 will be 1 with absolute. Negative 1 will be 1 also. So 2 will be 2. And negative 2 will be 2 also. And 3 and negative 3 will be 3. So this your function. We have symmetry 1, 2, 3, 1, 2, 3 here. So the symmetry at my vertex 0, 0. So I have to plot the order pairs, your order pair, you know the order pairs is negative 3 and 3, negative 2, 2, negative 1, 1, and so on. So this is your order pairs. You have to plot it in your graph like this. So this your function and we graph it. This is your absolute function. So we have to analyze now first the domain. The domain, all your real number from left to right. This is your end here. From right to left, this is your end here. So this is going to right, going to left. So your number line is your value of x, but your range is starting from 0 up to infinity. So from this 0, from y, we're going to up, y greater than 0, and here from 0 to up. So why am I starting from 0 and going to up, meaning to positive place, so y bigger than 0. So this is my analyze, or this is my description for this function. When x is 0 or positive, the graph can be represented by function f of x. Because of this, I told you from while this piecewise function. So this is the first equation, because this is the first piece. The second piece, I dealing with negative x. So this is your function. So because of this, I written this sometimes as piece of function like this. So f of x, I can cut or make this as pieces as f of x is x, first x, and bigger than 0. We're dealing with the bigger number with your domain here. And the second one, negative x, we're dealing with x less than 0. One of them is equal, the other not equal. It changes sometimes. Okay? Now we're going to something else. Here, that different here, I have something here extra with this function. X and plus 3. So something extra here. But the other one, if you remember, just x. So I'm dealing with x as 0, 0, 0. This is my vertex. This is my starting here. But here in the new example, I have something more. So if we take this, my vertex with change will move. We take it before in chapter 2. In quarter 2. We take it in quarter 2 together. I have to deal with this as equation. X equals 0. X plus 3 equals 0. So x plus 3 equals 0 here. I have to put it to the other side or make minus 3 minus 3. So x will be negative 3. So the first value or my vertex, I'm dealing with the inverse sign of this, negative 3. So this is my starting. So if I have to start with negative 3 here. If this negative, I will put it positive because I make this always equal 0. And the answer for this equation give me the vertex. This is the idea. So if I put this as negative 3, this will be negative 3 and 3 will be 0. So will be negative 3, 0. This is my vertex. Now I can take something after and something before. Anything I make here about 5 place, you can put about 2 or 3, doesn't matter. But you have to make it equal as you can. This all your answer will be correct. So I take something after, something before. I make it increasing to take the positive side. I try to reach to the positive. Because of this, I make this from positive number, but it doesn't matter. Now the other one, negative 4, negative 5. This is the positive and negative here, and this is my vertex. So I have to replace all these numbers in my equation or my function here. Then I have to find the answer for y. So if I replace it with negative 2 will be 1, and here with other one will 2, then negative 2 will be here 1 also, negative 2 and 0, and with 3 we have many things. Okay, we have many things. Now we're going to another thing. So we have here to find 2, 5 here to give you 5, 2 plus 3, 5. So this is your function. Now I have to represent it or plot it on my number line. So I found my version. It changed from here to here. This means if I dealing with function like this, I will go left, translate to left with negative 3. Because I told you before, I take this x. So my equation, if I make it equal 0, my x will be negative 3. This means the x will move it to negative 3. This is my vertex. So this is the idea here. Okay. Now I know my vertex, I plot the order pair, so I think everything is clear. Now I take the equation inside the absolute again. So this equation will give me 0. So my function here, I start here with 0. We have my key place or my key number here, 0. This will give me the vertex. If I put 0, will give me 3. So 0, 3 is my vertex. Okay? Remember that I take the equation inside the absolute, then I make it equal 0, so I know the value of x, mean the vertex of my x. Then I take something after, something before. Okay, this is the big deal here. Now we have to represent or substitute first to find my values, like this. If I put here 0 will be 3, put 1 will be 4, and so on. Okay, so this will give you the whole answer. Then I use the table to plot the order pairs, sketch the graph like this. So I found myself going to something here, 0, 3. 0, 3, this is my vertex. So this is my place. So I change it here, or we have a letter change. So the change from example 1, this without 3 give me this, with 3 will it change in y-axis because this outside of the absolute, so my moving or my new place will be on y-axis. So this clear. So the previous one, the 3 was inside the absolute, so we change on x-axis. But here is outside the absolute, this will be on y-axis this time, or move it on y-axis. So this is the difference. I hope you understand the difference now. Okay. Now we have to describe here, we add 3 inside and so on, because I add 3 here. This is the keyword or the my explanation here, because I have 3 next to the absolute, so I add 3 to the answer. So this is the result. Okay, I think this is the difference. This is the second one. This is example 2, this is example 3, this is the difference. Here I move it with x-axis, here I move with y-axis according to the x is outside or inside. Inside I move it on y, in x-axis, if outside will be on y-axis. So this example 3. Now I need to dealing with graph or mixed graph. So I need to make something like this example. I have here you compare between the absolute value and my quadratic function. So the quadratic function and absolute value have same domain. All of them are real number, the domain. And range y bigger than 0. Both are decreased for x less than 0 and increase for x greater than or equal 0. The behavior, the end of behavior is the same, and the x-axis of symmetry is the same. Both are continuous. both have minimum value at f of x equals 0. The value of the function can define it on equation. Two equations are needed to define it absolute value. Two equations give me absolute. This is because this piecewise function. Okay, I think is everything clear. Let's take exercise like guide practice, page 680, chapter 16, more functions and absolute function. Now, so I have to describe this absolute function. So I have to describe each one. So the first one here, 2 and 0. So the description here, what is the vertex? He needs what is the vertex for each one. So the vertex here is 2, 0. Here is 1, 2, 3 negative. So negative 3, 0. And here 0, 1. So 0, 1 is my vertex. Now the other description, how has f of x, the absolute a of x, been translated? Here translated with right 2, and here left 3, and here up 1. Write the absolute value. Here my absolute f of x, I move to right, mean positive, but I make it in my absolute as negative, the inverse. Here left, how many? 3. So x minus or plus 3 left. I make it with the inverse sign, mean plus, because if I change it equal 0 will be negative 3. Here up. So this mean my number outside of the absolute like this. So up 1 mean plus 1 for the function. I think it's clear and easy to dealing with this example or something like this example. Now we complete with the same one. Describe how function compare. Let's compare it. All three graphs are congruent and open upward. All of them looking to up and my vertex down. They have different axis of symmetry. So the axis of symmetry here, this is my axis of symmetry, this is my axis of symmetry, this is my axis of symmetry. So difference in this those functions are different in mine. The equation for the axis of symmetry is x equal 2, x equal negative 3, and x equal 0. Here x equal 2 as 2, negative 3, here 0, because I'm dealing with my x, so the x is 0 here. So the axis of symmetry or the equation of axis of symmetry mean the value of x of my vertex. So the domain, all of them, all real number in A, B, C, all of them the same, but the range is changed here. Here from 0 to infinity mean y bigger than 0 in A, B, but here y bigger than or equal 1, because my y here is 1. Now the vertices difference and minimum value, meaning my y are difference here. So they have difference minimum value, because the minimum value here at this point, here left, here up, so different. I think now you can make something like this example. You can make it quickly together. I have to discover my vertex because this outside it doesn't matter for me, so I have to put it 0. So this is the first number I have to dealing with. If I put it 0, will be negative 2. So 0, negative 2. I need something after and before 0. So this my numbers like this. So this is my vertex. And if I put it at 0, this will be negative 2. And if I replace all the number, negative 3 will be 3, minus 2 will be 1, and so on. This substitution, this is easy for you to find your result. Now we're going to another thing. Now we plot. The function is open upward to describe it. And we have the axis of symmetry at this point as 0, x equals 0, the vertex. And this minimum value, the minimum value is y equal negative 2 or 0, negative 2. Both of them are correct. Make it as a order pair or make it as y equal negative 2. Both of them are correct. So this my domain, all the real number, and the range I told you before, y bigger than negative 2. So there are many. There is a minimum value at a point 0, negative 2. My graph will be like this: 0, negative 2. This is my starting. I put it the other side. This will be good. Now we have to graph this. The same idea for the previous example. I have to put it 0. This is my starting 0. will be 0, -1, 0, -1 will be here in this place. Okay, then I take something right, something left, make my table. So this will be my draw. Is enough. If you make one right, one left, one more, one less for 0, you will have your equation, your function, or your drawing, your table. So is the function continuous or discontinuous? So continuous, why? You can draw without lifting your pencil. So you make it like this, without any gaps here or open circle like the last lesson, if you remember. What the domain always here, I told you real number, but the range from -1 or y bigger than -1. Now what's the equation? I told you the equation here will be my value is 0, -1. So 0 is my equation of the value of x. Does the function have minimum or maximum? So it's minimum. It's clear for you, 0, -1. And is the function linear, step, piece, y is quadratic, exponential? So this piece function, y equal x, and x bigger than 0, y equal -x, and x less than 0. Okay, now we're dealing with two functions. We compare the last example, this one, and this exponential function. We need to compare between them. If we have f of x 2 power x, we put 0, 1, something after some before. We have this graph, we take it before together in quarter, I think also 2 or 3, I can't remember, but we take it together. We put the starting with 0 or something more, something less, make your table, you have this graph. Now we have to compare. The pose function are continuous, so we make it as one step without lifting your pencil. You make it as one part, so without any gaps. So this continuous, both of them. Both have the same domain, because this going to left in the x-axis and going to this direction mean I complete with the positive direction is of x-axis, so the domain all real number, and here also all the real number. Now we're going to the range of exponential function. Y here bigger than 0. But here y is bigger than -1. So this is the difference here. So the range are different, exponential function and absolute function. F of x has no minimums, no minimum here. I don't know where is the minimum, because this continuous is no minimum. I don't know where is the place here. And the absolute value has minimum at the vertex point, this point 0, -1. The exponential function is defined by one equation. Here, one equation. But here, I have two piecewise equation, one positive, one negative, because we're dealing with absolute function. So this, my things, I think everything is clear here. Can you expression f of x, this have value of f of x less than 0? No, the meaning of absolute value tell. I give you the definition in the first, from 0 to any number positive all the time. So we're dealing with the positive. So the meaning of absolute value tell the function always going to be 0 or positive. This is the first definition I give it to you when we start this lesson. Can the expression f of x -1 have the value for f of x less than 0? Yes, because one subtraction we have here minus here. So maybe this has changed a little bit my result with something else, from positive to negative, but here is no something adding or subtracting, especially subtracting, so it's no change for my sign. But here maybe my sign is changed here. If I put a 0, will be -1, so we have a change in this case. Okay, now here we're dealing with quadratic and absolute in the same time. So take this alone and make it with any numbers. You know you have number less than 3, so anything less than 3 but not equal 3, I will make open circle, like I told you the last lesson, here, and make my table. So we have this curve. Then I make the absolute with the same to another table I have, but with here x bigger than 3. If I change it here, will be change it a little bit, but it will be this. So this is my function. Here I change it like this. So it will be good if I make it like this. In description, you describe the domain, everything continuous, piecewise, anything you give me all your information like you have. So if you know the deal here, you can dealing which one here give you this function. So I think the correct answer is this one, because here if we have positive, I give you something before with the quadratic function, the leading coefficient. So the leading coefficient is controlled. Make a control with my function. So if this negative will be downward, if this positive will be upward, like the quadratic function we take it together before. So this, the leading coefficient, is determine my direction for my function. So this is my best one. Why? I have another one, so I have to discover here. If I put it 0 here, this will be gone. 0 and here 3. So if I put it as 0, will be 0 and 3. So 0, 3 here, not here. This is not 0, 3. So this doesn't work with me. This is the best one. If I dealing with 0 here, giving 0, 3 is 0, 3, and this negative, so the leading coefficient tell me it changes the direction for my function. Or you can make it as table, but it take long time, but you will have the same answer. This function represents the graph. Which function here represents this graph? I'll give you a few seconds to discover. You have here your vertex, you have to change. We have two things here, it changed. My direction was x, my direction was y, so I have to change it with x and y. So give you a few, yes, I think you discover this your answer, because here I changed this to become 2, but this is still with the same sign, so it will be 2, negative 4. 2, negative 4. So anything inside the absolute, I change the sign, will be 2, x, the value of x will be 2, and the outside will be the other part of my order pair, will be 2, negative 4. I want to send your homework soon and see your answer to discover you understand or not. I think it's easy lesson. See you inshallah soon, but I want from you to revise the old